Hello, welcome to Unacademy. And this is Sunil Manjani. So, uh, Unacademy is India's largest learning platform. Okay, it is a subscription-based platform. So, let us see about myself first of all. Okay, myself Sunil Manjani. I got 15 plus years of teaching experience. Okay, I mentored many students for GATE ESE and semester exams. Okay, cracked many exams like GATE, HL, MAR, DISCOM, and MARG and Co like that. So this is about myself. Okay. So let us move on to how to use an academy learning app. Okay. Please see this. Step one, you need to go to Apple App Store or Play Store and type in an academy. You will be required to. You can select this an academy learning app. Okay. You will be prompted to install it in step two. Okay. Step 3, after all permissions and all that, like you go to manage goal in an academy learning app and click on your goal, GATE and ESC. So this is GATE and ESC. Go to plus. Okay. You will prompted to get the subscription. Okay. In step 5, step 6 will give you two types of choices, plus and iconic. If you are selecting plus, the plan is for 12 months, it is costing 27 to 25. For 24 months, it is costing 39,600. Okay. If you are selecting iconic plan for 12 months, it is costing 45 to 25, and for 24 months, it is costing 66,600. Okay. You can get further discount on each subscription. Okay. By typing SSM10 as the code. Okay. So you can type SSM10 as a code. Okay. So what is plus plan? Okay. So plus plan will give you India's best. Plus plan will give you India's best educators. Okay. Interactive classes, live classes. Okay. Structured courses, live tests and quizzes. Okay. So iconic plan will give you India's best educator, interactive live classes, structured courses, and live tests and quizzes. As in plus plan, plus you will get a personal coach, you will get a personalized test analysis, you will get a study planner, you will get a preparatory study material. Okay, so two types of courses you will get. Okay, so let us start with our Matlab fundamental course. Okay, today we are going to cover functions. Okay, so today's contents are functions. We have seen what are the function and function call yesterday. Okay, we will see one example. Okay, example on function. Okay, so problem statement is, so statement of problem is here to create and test two functions dr and RD, okay, to change degree to radians and radians to degrees. Okay, this is problem statement, step number 1. Step number 2 is to define input and output. Input and output. Okay. What are inputs? Vector, or degrees, degree values. Okay. Another input is a vector of radian values. Okay. Third, okay, in this second, we need to write down the output. Let us see table of degrees to radians, that is output, and table of radians to degrees is another output. Okay. So what is step number 3? Step number 3 is hand example. Radians into 180 by pi, and radians is equal to degrees into pi by. Okay. So we'll see degrees to radian. So degree is 0, radian is 0. Degree is 30, radian is 30 into pi by 180 equal to pi by 6, that is 0.524. Degree is 60, this is 60 into pi by 180, that is equal to pi by 3, that is 1.047. 90 degree is 90 into pi by 180. Pi by 2 is equal to 1.57. This is degree into radians, like this. Okay. Okay. Then next comes is fourth, develop a Matlab solution. Okay. So what will be the Matlab program look like? Clear all CLC. Okay. So degrees you will define. Degrees is equal to 0, interval of 15 is to 180 degrees. Okay. Then you define function call. Function call. Which function? Degrees to radian. Okay. So it will be, you need radians, so output radians is equal to degree to radian dr in bracket input, that is degree. That is degree. So this is a function call. Okay. So next one is to create a table. A table. Okay. So degrees to radian is equal to degrees is input and radians is output. Okay. You write down display a table of degrees to radians. This will be displayed as it is. Okay. Again display degrees space radian. Okay. So this is okay. Then you have to print. Okay. So f printf, I will write down percentage 6.0 floating point integer or fixed point integer for degrees, percentage 8.3f backslash n. This is for radians. Okay. So this will be degrees underscore radians. See here, degrees underscore radians, there are two arguments, degrees and radians. Therefore, there are two memory slots or location or memory capacity defined. Okay. So this is degrees and radians like this. Okay. So I will write down a blank space, blank row. Okay. So display just blank. Okay. So now we'll define a radian. So first this program we'll write down. First this program we will write down. So let us see in on hands-on. Go to new script rather. Okay, so it will be clear all CLC. Okay, degrees equal to, first of all it will be 0, then 15 degrees, then 180 degrees. This, okay. Then you'll call the function radians equal to degree to radian dr input degrees, okay. Then store these values in a variable having two arguments, degrees and radians. So this is, okay. So you will write down display a table of degrees to radian. Table of degrees to radians. Degrees to radians. Okay. Display degrees and radians. Okay. So fprintf, okay. So first of all 6.0 f, this is in percentage, okay. Then 8.3 f, like this, okay. So then a new line \n, okay, comma, call the variable degrees underscore radians, okay, bracket closed. So this is, then I will need a blank space and I will save this. Okay. This is not the function we are defining. This is a program. Degree to radian. We have still to write down the function. Remember that. Okay. We have still to write down function. So first of all, we have written down the program. Okay. So let us see in exercises. I will save this as degree to radian. Okay. Then I will write down the function. I will write down the function. What is the function? First function name, that is function. Then output variable is equal to function name. Now declaration function name, that is dr. What are the inputs? Input was degree, only one input, so a dummy variable x. Okay, then I will write down the function of this function. That means what it does, output is equal to input x star pi divided by 180. It converts degree to radian. So this function ends here. Okay, you have to name this as dr because function name is dr. Function name is dr. Again calculate, take out this, then you have to run this one. What I will do, I will copy this file here, go to F colon, go to an academy, then I will go to exercises and paste here this function dr dot time. Okay, so I will write down the function degree rate. So you can see. Okay, now I will refine this. I will refine this so that the output is much clearer. Okay, so what I will do is I will increase this space, suppose like this, save. Okay, then again I will degree radian. I will run the program. So see here, a table of degrees to radian. Degrees are like this and radians is like this. So in this way you can find out the program. You can find out the program. Okay. Now what we will do is we will utilize this program only to calculate radian to degree now. Okay. For that I will say radians. Again I have to redefine radians. Radians is equal to 0 to pi by 12, suppose 2 pi. Radians I have defined. Okay. Then I will call the function. Input output is degrees, so I want degrees. Okay, is equal to radian to degrees is a function, and input in radian to degrees is radians. This is the okay. So radians degrees is equal to radian to degrees in radians. Okay. Then I will say display a table of a table of radians to degrees. Table of radians to degrees. So this is table of radian to degrees. Okay. I will say display. Input is degrees. Oh, sorry. Input is radians. Output is degrees. Okay. Then I will say printf. Printf. Okay. Suppose radians. So I will pick a figure value 9.3 f. Then I will pick a more bigger value for degrees 10.3 f. Okay. Then backslash n, new line, new values, new line. Okay. Then I will say we have not defined a single variable like we did in degrees and radian. Degrees and radians. So we will define that one, that is radians, degrees, degrees is equal to radians semicolon degrees. Okay. So this is equal to radians to degrees. Okay. This is f printf. This is a function program. We need to define one more function, that is we write down function as it is, space, output is equal to radian to degrees, input is x. Okay, what this do? This calculate output is equal to x into 180 divided by pi. We'll end this one. We will save this in the name of, where we will say, we will again save this in f colon Unacademy exercise RD, and then okay. So again we'll go to program. So this are two programs running. Okay. We'll write down degree radian like this. there was one mistake, so we'll run this and we'll see what is the degree radians. Let us see the function program. Spelling mistake, this is output. Okay, so now you will get the answer. So you can see radians to degrees conversion is also there. Okay, so in this way you can write down the program. Which program? Function program. Okay, function program you can write down. And let us now move on to next value, next article, that is statement level control system, control structure. This is applicable to any general program. Applicable to any general program. Okay, may it be Matlab, may it be C programming, may it be C++, all that. Okay, so you can see that any computer code, so any computer code is categorized is categorized categorized into three structures, into one of three structures. First one is sequence. Okay, second one is selection structures, and third one is repetition. Structure. Repetition structure. Okay, sequence is like that, like this sequence. What about selection? Some sequence is there, then you can follow alternate part depending upon the selection, right or wrong, yes or no, like this. Okay, what is repetition? Some sequence is there, then there is a repetition or looping. Okay, so there is looping. So loop is formed. Right. Okay, so this is your repetition structure. So this is repetition structure and loop is formed. Okay, something about this we'll see. What is sequences? Sequences are lists of command which are executed one after other. Selections. Okay. So these are list of commands executed by program on certain true and false conditions. True and or false condition. Otherwise, these are not executed. Okay. These conditions are called as logical condition. Logical condition. Okay. This logical condition contains relational and lo- logical operators or functions. Or function. Okay. So this contains relational logical operators or functions. Okay. Now we'll see what are logical operators. Relational or rather and logical operator. Okay. So suppose x equal to 5, y equal to 1. Okay. One relationship operator is less than. So y is less than x. Y is less than x. Okay. So if I enter this like this, my answer will be what? It is truth, therefore 1. If I enter x less than y, my answer will be 0 because this is not true. X is greater than y. Okay. So one of the logical relational operator is this is relational operator. Okay. So this is relational operator. So let us see. Relational operator and interpretation. Okay, so we'll define relational operator. Less than, this is less than, less than equal to, or equal to, greater than, greater than equal to, then, or equal. Equal means equal to, not equal to means this, not equal. These are relational operator, these are some interpretation of relational. Okay. So let us see one more program on this one. So suppose we are writing x equal to 1 is to 5 and we are writing y equal to x minus 4. Then I am saying x less than y. X less than y. Okay. So see how the program will be calculating this. How the program will be calculating this. Program control is x is 1 is to 5, so it will display x equal to 1, 2, 3, 4, 5. Program control is on y, so y equal to x minus 1. This is 1 minus 4. This is minus 3. This is 2 minus 4 is minus 2. 3 minus 4 is minus 1. Okay. 4 minus 4 is 0 and 5 minus 4 is 1. I am saying x is less than 1. I am saying x is less than 1. Okay. X is less than 1. So if I am saying x is less than 1, okay, it will give you, when I hit enter, it will give answer equal to. See here, x is less than 1. Which one is less? Y is less. X is not less. Y is less. So it will give you 0. Here y is less than this x. Again it will give you 0. Y is less than x. It will give you 0. Y is less than x. It will give you 0. Y is less than x. It will again give you 0. So this is the answer. Okay. I will write down one more program. Okay. One more program. Okay. So x is equal to 1, 2, 3, 4, 5. Okay. 1, 3, 4, 5. Okay. Y is equal to minus 2, 0, 2, 4, 6. This is equal to, okay, and I am saying x less than y. What will be answer? What will be answer? answer will be equal to 1. This is y is less than 1, not x less than y. X is greater than 1. Answer 0. X is again greater than y. Answer. X is again greater than y. Answer 0. X is equal to y. Answer 0. Now x is less than y. Answer 0. So this will be your answer. Okay. This will be your answer. Okay. So this is how relational operator works. Okay. Next is logical operator. Okay, there are three logical operators basically. First operator is AND operator. First operator is AND. Interpretation is AND. Second operator is NOT operator. Interpretation is NOT. Third operator is OR operator. Interpretation is OR. AND basically implies multiplication. NOT means negation. OR means addition. Like this. So I have written down the program. Let us see. X equal to 1, 2, 3, 4, 5. Again same, y is equal to -2, 0, 2, 4, z is equal to 8, 8, 8, 8. Now we will see. I will write down z greater x and z greater x, z greater y. We will see what is the output of this. We will see output of the program. First of all, we will see z greater x, element by element. Means 8 is greater than 1, so here logical operator will be 1. 8 is greater than 2, again logical operator 1. 8 is greater than 3, logical operator 1. 8 is greater than 4, logical operator 1. 8 is greater than 5, logical operator. Okay. This is for z greater x. This is for z greater. Let us see for z greater y. Okay. 8 is greater than -2, so logical operator 1. 8 is greater than 0, logical operator 1. 8 is greater than 2, logical operator 1. 8 is greater than 4, correct, so 1. 8 is greater than 6. So this is AND operator, AND operator, AND operator, AND operator, AND operator. Okay. So naturally I want answer, output. By using logical operator 1 and 1 is equal to 1. 1 and 1 is equal to 1. 1 and 1 is equal to 1. 1 and 1, that means high and high is equal to high. High and high is equal. So this is my output. If I press enter here, I will get answer equal to 1 1 1 1. I will get this answer. I will get this answer. Okay, so this is operator, logical operator. Okay. I will consider same inputs. I will say, I will write down output as x greater y, or operator x greater z. X greater z. What output I will get? What output I will get? Not visible. We go with black. Okay. So x greater than y. See here, 1 is greater than minus 2, so it will return 1. 2 is greater than minus 2, yes, so 1. 3 greater than 2, yes, 1. 4 greater than 4, no, 0. 5 greater than 6, no, 0. Okay, then I will go to these values. X greater than z. X is never greater than z, because z is always greater than x. You can see all the values, so it will return 0 all the way. 0 all the way. This is OR operator. So OR, 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 OR. It is like a addition operator. It is like a addition operator. Okay. So what I will get in the answer? In the answer, I will get 1 plus 0 is 1, that is 1. 1 plus 0 is 1, that is 1. 1 means high plus 0 means low, that is 1. Low plus low is 0. Low plus low is 0. So what will be the answer? Answer will be 1 1 1 0 0. 1 1 1 0. This will be your answer. Okay, this will be your. This is for logical operators. This is for logical operators. Okay, so let us see. Next is equal to selection structures. Selection structures. So selection structures are two types: find command or if command. Find command or if command. Okay. So find command is very unique and it is often used in Matlab instead of if or loop command, loop structure. Okay. Okay. So we'll see one example of this command. We'll see a manufacturing process. Manufacturing where we got temperature ranges like this. Okay. Now if I say temperature of any widget is greater than 95, then it is faulty. Okay. So what I will do is I will write down the program. Okay. I'll write find function. Find temperature greater than 95. Okay. Greater than 90. What will be the answer? Is this greater 95? No. Is this greater 95? No. This is greater 95. Oh, sorry. Whose temperature is less than 95 is faulty. Less than. Okay. I'm sorry. This is less than. Is this less than 95? No. Is this less than 95? No. Is this less than 95? Yes. So this is how many elements? 1, 2, 3, 4, 5. So third element is temperature is less than 95. So it will return third element. 101 less than 95? No. 93 less than 95? Yes. It will return fifth element. 5. Okay. Number. Okay. So this is okay. If I say temperature is equal to, again I will write down those temperatures: 100, 98, 94, 101, 93. Temperature less than 95. Relational operator. What will be answer? 100 less than 95? No. Therefore 0. 98 less than 95? No. 0. 94 less than 95? Yes. So 1. 101 less than 95? No. 0. 93 less than 95? Therefore 1. Is yes. Okay. Okay. So again I will write down some command like faulty is equal to find temperature less than 95. Pass is equal to find what remains. Less than 95 is there, therefore temperature greater than or equal to remains 95 this will be past. Okay, so I will write down fail table is equal to faulty transpose comma temporary faulty. Okay, when I hit the enter button here, I will get fail table is equal to what are faulty, which one is faulty, fail table faulty transpose 3 and 5 in a column form. Temporary temperature of faulty, what is temperature of this third element, 94. What is temperature of fifth element, 93. Okay, this is row and column, sorry, row form. Okay, so we'll do one hands-on example. Before that, we'll write down the example. What is that? X equal to 1 comma 2 comma 3, 10 comma 5 comma 1, 10 comma 3 comma 2, 8 comma 3 comma 1. Element, find x greater 9. Row comma column is equal to find x greater 9. Okay, if you hit the button here, enter, you will get element is equal to, remember we have not put any semicolon, so this will be executed and displayed in the output. X greater 9. Is this greater 9? No. Greater 9? No. Greater 9? No. Yes, this is greater 9. Okay. This one is greater 9. This one is greater 9. Okay. So here, see here, x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I want to display it like a serial number, oh sorry, not 4, 5, 6, I will write down this once again. Okay, x is equal to 1, 2, 3, 10, 5, 1, 12, 3, 2, 8, 3. I want to display this as a table, serial number, as a serial number. So this is serial number, value, again serial number, value, again serial number, 1, 2, 3, 4, 5, 6, 7. This is 9, 10, 11, 12, 13, 14, 15. What are the values? First value is 1, second value is 2, third value is 3, fourth value is 10, fifth value is 5, sixth value is 1, seventh is 12, then 3, then 2, okay, okay, then 8, then 3, then more. So this 10 and 12 are greater than 9. 10 and 12 are greater than 9. Okay. So which element for 10? This is fourth element. Okay. This is just a minute. This I have written down incorrectly. Let me erase these values. Okay. So I'll write down correctly this one. So first value see here, like this we will go. First value is 1, second value is 10, third value is 12, fourth value is 8, fifth value is 2, sixth value is 5, seventh is 3, then eighth is 3, then again ninth is 3, 10th is 1, 11th is 2, this is again 1, like this. Okay. So you can see that, okay, you can see that this value is greater than 9, 12 is greater than 9. So this value is how much? This is 2. 12 is how much? 12, where is 12? This is third value. This is third value. Okay. So this is third value, this is right. Okay. So your answer will be 2 and 3. Okay. When you say row, you will get one input here. This input, find x greater than 9. Row. Okay. Row is x greater than 9. Which row? Row is x greater than 9. Okay. Second row. This second row. Okay. Which element is greater than 9? 12. Row of this is third row. Third row. Then we will come to, this is row equal to column equal to, this is greater than 9. What is column? first column, first column. What about this 12? Again this is first column. Again this is first column. Okay, so in this way you will get the answer, element, row and column, like that you will get the answer. You will get the, okay. So in this way you can define the find function. Okay. Okay, we will see one more example, detailed example of sync function. Sync function. This is used in signal processing. Signal processing. Let us see processing. Okay, so we will see the example problem statement. Problem statement. Let us see the example. Okay, what is problem statement? Create and test function called sync underscore x using second definition, using function f2x is equal to sin x divided by x. Second is describe the input. Describe the input and output. Input. Let x varies from minus 5 pi to plus 5 pi. Output. Create a plot of sync x versus x. Okay, so what is third step? And example. So we'll calculate the function. First the value of x, then sin x, then sync x of x is equals to sin x divided by x. X is 0, sine of 0 is 0, sine of 0, that means sine of 0 is 0 divided by 0, that is equal to 1. Pi by 2, this is 1, this is 1 upon pi by 2, this is 2 by pi, that is equal to 0.67. This is pi, sin pi is 0, 0 by pi is equal to 0. This is minus pi by 2, minus 1. This is minus 1 upon pi by 2 is equal to 0.63. This is end example. Okay. So let us see Matlab solution. Matlab solution. Okay. So function output is equal to sink of x into x. This is function declaration. Okay. Okay, what we'll do now, we will see which values are close to 0. Which values in x are close to 0, we'll set those value as 1. Close to 0, we'll say those as 1. Okay, so we'll say set 1 is equal to find absolute value of x which is less than close to 0, less than 0.001. Then we'll set these values to 1. Then output set of 1 is equal to 1. Set of 1 is equal to 1. Okay. We'll see which values are not close to 0. Set 2. Find absolute x greater than or equal to 0.0001. Okay. So I will find output of set 2 is equal to sine of x set 2 dot x set. Okay. Then we'll find out the sink function. Sink function. So this we will find out. This we will find out and create the problem. Create the solution. Which solution? This hand example solution. Hand example solution. Which value will put in 0 pi by 2 pi minus pi by 2, like this will put in as the input argument. Okay, let us do it hands on. Okay, let us do it hands on. New script file. Okay, clear all. TLC. Okay, so I will say function space output equal to sink x of x. Okay, next set 1 equal to find. Before that we need to define what is the value of we'll define, which is, see here, absolute x less than 0.0001. We'll find which are less than 1 or close less than 1, this value or close to 0. We will set this as output. Set 1 equal to 1. Set this value as 1. Okay. We don't want this to be reminded. So like this. Output set 1 equal to 1. Now we'll say set 2 equal to find absolute x less than, sorry, greater than, equal to 0.123 zeros, then 1. Okay, we'll say set this as output set 2 is equal to, output set 2 is equal to sin x by x, sin x of set 2 which are not close to 0, set 2. Okay, by x array, so dot star dot slash x of which are not close to 0. This is like this. Okay, this is output only, not p output. Output. Okay. So this is how you, what will be the name of this? Sync x of x. This is a function. Okay, this will be sync x, like this. Sync x. We'll say end. Save it. Now we will test. We will test. Okay. How we'll test? We'll find the new script file. We'll test. Instead of new script file, we can solve it on Matlab command also. Simply. Okay. So CLC. See here. Okay. Sync underscore x of first value x is 0. Okay. This is It's every time it is clearing, so remove this. Let us see, it is clearing, therefore it is problem. Let us see. Okay, so it is sync x of 0 answer is equal to 1. We know that. Okay, hand calculation. You can check. Sync 0 answer is equal to 1. Okay, again go to Matlab window. Sync x of pi by 2. Pi by 2. Answer is 0.6366. Go to hand calculations. Pi by 2. 0.637. Similarly, for pi it will be 0. For minus pi by 2 it will be minus 0.637. Go to command window. Sync underscore x pi. Okay. See here, e raised to minus 17, so almost 0. This is 0. Okay. So sync underscore x minus pi by 2. Okay. Why sign is not represented here? Why it is not minus? Because it's this Matlab treats this as a floating number. Okay, floating number. Therefore, this approximated to real value. Approximated to real value. Okay. So this is one example. Okay, now we'll find one program, write one program for this one. Untitled, we'll see. Okay, we'll see clear all CLC. Okay, x equal to, problem statement was minus 5 into pi by 100 is the interval. This is 5 into pi. Pi into pi. Okay, so y is equal to sync c underscore x of x. Okay, so we will plot x comma y, plot x comma y, put a title. This is sync function, okay, x label angle, y label this is sync. Okay, we'll save this. You can save this any sync plot. Okay, execute this. You can see the sync function plot. Okay, you can see the Sync function plot. This is used in electrical engineering problem. Electrical engineering problem. Okay. So this is sync function plot. Okay. So sync function plot. So this is one hands-on example for us. Let us move on to another topic. Okay. Next topic will be if, else if, and else if statement. Okay. First one is if statement. Okay. So the syntax is if some comparison, okay, then some statement will be executed if that comparison is true. Statements then end. Okay. This comparison will involve relational and logical statement. Logical statement. Okay. So okay. So let us write down one program. Okay. G is equal to suppose 15. Okay. Now if G is less than 50, count equal to count plus display G. And this is the function. Okay. Initially we have to initialize the count function. So initial value of count is 0. Okay. So this is like this. Now how the dry run will be? Dry run means how the program will flow. Let us see. Count. First program will be here. So G value will be 15. Count value will be 0. Now then structure will be G less than 50. If G is less than 50, what is the value of 15? G 15. It is less than 50, so it is true. It is true. So if this is true, count will be incremented by 1. Count plus 1. Initial value of count was 0. So your count will be equal to 0 plus 1, that is equal to 1. Then display G. Display G. Okay. And end. So if you execute this, what will be the output? Output will be G equal to, sorry, count, sorry, display G, okay, G will be equal to how much? 15. If you want to display count, it will be displayed, okay, display count, it will be displayed, count equal to 1, count equal to 1, like this. Okay, let us write down if else statement. If, sorry, else statement, else. Okay, it will be like this. If condition, okay, is true, X, then statement 1. Else, if this is false, then statement this end. This is like this. This is like this. Okay. See, we will see the example. We will see the example. Okay. Okay. With hands on. With hands on, we'll see the example. Okay. Or with here only we'll see the example. We'll see the hands on example little later. Okay. So we'll see the example. Okay. So we'll see interval is equal to 0, 0.5 and 2, like this. Okay. If interval is greater than, oh, sorry, less than 1, if interval is less than 1, x increment is equal to interval divided by 10. Okay. Else x increment is equal to 0.1. Then end. Okay. Then end. Then end. So let us see what will be the output. First of all, let us see the interval. Interval is equal to 0, then 0.5, then 1.0, then 1.5, then 2, like this. Okay. Next statement is if interval is less than 1. Interval x increment. Okay. What will be x increment? First comparison, 0 is less than 1. Yes. So value is true. True means first statement will be executed. Interval by 10, 0 by 10. What is 0 by 10? 0. Next is 0.5. Okay. 0.5. 0.5 will be what? It is less than 1. So true. So 0.5 divided by 10 is equal to 0.005. Sorry, 0.05. 0.05. Then 1. 1 is not less than 1. So false. So increment is now second statement after else. X increment is 1. Sorry, 0.1. Next is 1.5. Less than 2, less than 1. No, it is false. Then 0.1. Then 2 is 2. Less than 1. No. So statement is false. So second statement will be executed. 0.1. So what will be x increment? X increment will be what? 0, 0.05, 0.1, 0.1, 0. Okay, let us try this hands on. Okay, let us try this hands on. Clear all. CLC. Okay, interval is equal to 0, 0.5 to, okay, then write down if interval is less than 1, x increment is equal to interval by 10. Else x increment is equal to 0.1. This is end. Save this. Okay. If else, example 1. If else 1. Let us make some correction. X underscore increment. Save this. Run this one. Okay, this gives you last value of x increment. This gives you last value of x increment, that is 0.1. Okay, 0.1. Let us move on to another hands-on example. Okay, hands-on example. Okay, clear all. CLC. Temperature is equal to 90 space 95 space 101. Okay, now if temperature is greater than 100, our statement is display two hot equipment malfunctioning. Two hot equipment malfunctioning. Okay, this is else if example. Okay, else if there are more than two conditions, then we have to write else if condition. Else if temperature greater 90, greater 90. Okay, then we'll display normal operating temperature. Okay, write down else if temperature greater 50, greater 50. Okay, temperature greater 50, display temperature below desired operating range. Okay, so this is else if you want another statement after this statement, then else if you want to close the statement with last, so else. Okay, display too cold. Okay, turn off. Then you will write now end statement. Save this. Else if one. Okay, execute this, we'll get the answer. Temperature below desired operating range. It is was for 101. Okay, temperature below desired operating range. Okay, this is the answer. This is the answer. So this is else if else statement. Else if else statement. Okay, so we'll see one more example of else if else statement. Okay, let us see. We will develop the Matlab solution. We'll develop Matlab solution. Okay. So function result is equal to grade x. So we will put on the grade. Grade A means 90 to 100, grade B means 80 to 90, grade C means 70 to 80, grade D means 60 to 70, and grade A means less than 60. Okay. So grade A means 90 to 100 means if in bracket x is greater than 90, 90 to 100 means greater than 90. There cannot be greater than 100, isn't it? So greater than 90 degree. So I will say result is equal to A grade. Okay. Else if x next grade is B, 80 to 90. 80 to 90. Okay. It is greater than it is greater than equal to 80, greater than equal to 80, results is equal to B. Okay. Else if x is greater equal to 70, okay, result is C. Okay. Else if x is greater than equal to 60, greater than equal to 60, results D. Else results equal to E, like this, then end. Okay, so this is saved. So this will be saved in the name of function name. Function name was results, sorry, grade. Okay, so function name is grade. You can see grade. Okay, so save this again, then we'll execute. What we'll see, grade 25 will pass on the argument. There is one mistake here. Fine. So we'll see, syntax error was there. Grade 25. Okay. So we'll see what is the results. So E. Results E. Grade 80. Results B grade. Okay. Grade minus 52. Results E. Grade 108. Undefined variable. Okay, sorry. Yes, grade 108. So result A. Result A. Okay. In this way you can get the function. Okay. You can get the function. Okay. So this is the problem for which statement? If else if. Okay. If else if statement. So we'll conclude here. Okay. Tomorrow we'll see some loop structures. Some loops we'll see. Okay. In tomorrow's class. Don't forget there is a special class today at 6 p.m. Okay. So in which we are working with Matlab operation. Okay. So some more example will take on this special class. Okay. So thank you very much. Okay. So now how to unlock free plans on Unacademy. So go to Unacademy Learning app. Okay. Click on daily interactive live classes. Click on manage your goals. Popular goal is GATE and ESE. Okay, for GATE and ESE you go click on this subscription plus. Many videos will be displayed. Suppose you want this free course to avail. Okay. So on this, click on this video. You will be prompted to put in the invite code. Okay. Put the invite code SSM10 and press unlock. This free stuff will be unlocked for your viewing. Okay. So this is how to get unlock free plan on Unacademy. Okay. So please like us. Okay. Comment on YouTube, like, comment, subscribe, and hit the bell icon for notification. Use our code SSM10 for further discounts and unlocking the free plans. Okay. Use our Telegram channel for more updates on our upcoming videos. Okay. So thank you very much. This is Sunil Manjani signing off for today.